Hello, this is Alex Yazdani. This is a final project demo video 4 for EE533 in the spring of 2025 with Professor Young Cho. My lab partners are Szymon Gorski and Tim Liu. Professor had mentioned in class that for our final demo, we shouldn't have a demo that's too toyish. Since the FPGAs, we can really only implement so much. It's not fully scalable on the FPGA itself. We don't want our demo video to kind of ruin the overall promise of the product itself. So we should do some of it in software and then say that this is, we know it's capable of this, but then show what we're actually doing on hardware as well. So right now I've kind of built up a bit of a software demo to go along with our hardware demo. So let's just get that started. So just some reminder, what we're doing is we're building a product that's based off the paper Dark Knight, and it's for image security. We actually encode the images themselves before we send them off to an AI model. So right here I have a bunch of images. I'm a bit of a Star Wars fan, so got some Star Wars characters and some other characters here. And then what we've done here actually is we have split these up into the different RGB channels so that we can encode each individual channel and then recombine them. So that's red, of course. Then we have green, and then here's blue. And then when we encode them, it looks like this. Now, you can actually kind of make out some of the characters' features here, some of them more than others. I've definitely noticed that, characters that have very crisp and contrasting lines are easier to pick out here. So definitely the more images that you put into your batch size, it will definitely help. And also, you can change the proportion of images that are your noise images. So right now we only have one noise image, so it's not masking as much as we could if we were using more. And then finally, we decode, and yeah, we're able to receive the images back. And this is actually decoding. These aren't the original images. These are the code I have here. You probably can't see, but I'm doing a matrix multiplication with a bunch of random noise, all of these images plus additional noise, and it's then decoding with the inverse matrix, and yeah, it actually works. So yeah, from here our plan is to just show this actually working on hardware with a much smaller scale, which we know we can do, so stay tuned for the final demo to see that. And then we'll show this just to show the promise of its scalability. But of course, we also want to show it working on hardware as well. So yeah, that's it for this week. Thank you.